Aircraft Design and Systems. Welcome to an exploration of the fascinating world of aircraft design and systems. Today, we'll look into innovative aircraft design, manufacturing techniques, electric propulsion, hypersonic travel, biofuels, autonomous flight, the next-gen flight deck, digital flight controls, fighter jet technology, and synthetic and enhanced vision systems. Let's take a detailed journey through these transformative elements, shaping the future of aviation. Innovative aircraft design. Innovative aircraft design is at the forefront of revolutionizing the aviation industry. Modern aircraft are designed with advanced materials, aerodynamics, and technologies to enhance performance, efficiency, and safety. Composite materials, such as carbon fiber and advanced alloys, reduce weight, while increasing strength and durability. Aerodynamic improvements, including optimized wing shapes, and integrated winglets, reduce drag, and improve fuel efficiency. These designs not only enhance the operational capabilities of aircraft, but also contribute to sustainability, by reducing fuel consumption and emissions. Advanced manufacturing techniques. The manufacturing of aircraft has also seen significant advancements. Additive manufacturing, or 3D printing, allows for the production of complex and lightweight components, with unprecedented precision. This technique reduces waste, and speeds up production times, leading to more cost-effective manufacturing processes. Automated and robotic assembly lines ensure consistent quality, and reduce human error. These advancements in manufacturing are crucial for meeting the growing demand for new aircraft, while maintaining high standards of quality and safety. Electric propulsion. Electric propulsion is emerging as a promising technology for the future of aviation. Electric aircraft, powered by batteries or hybrid systems, offer significant advantages in terms of efficiency and environmental impact. Electric motors are quieter, produce zero emissions during flight, and require less maintenance, compared to traditional jet engines. Companies like Airbus and Boeing are investing heavily in developing electric aircraft for short-haul routes, with the potential to revolutionize regional air travel, by making it more sustainable and cost-effective. Hypersonic travel. Hypersonic travel represents the next frontier in aviation, promising to dramatically reduce travel times, by flying at speeds greater than Mach 5. Advances in materials, propulsion systems, and thermal management are making hypersonic flight more feasible. Hypersonic aircraft would enable passengers to travel from New York to London in under 2 hours, revolutionizing long-distance travel. The development of hypersonic technology is also driven by military applications, with the potential for rapid deployment and global reach. Biofuels? Biofuels are playing a crucial role in the aviation industry's efforts to reduce its carbon footprint. Sustainable aviation fuels, SAFs, derived from renewable sources, such as algae, waste oils, and agricultural residues, can reduce life cycle greenhouse gas emissions by up to 80% compared to conventional jet fuel. Airlines and aircraft manufacturers are actively testing and adopting biofuels to meet sustainability goals. The use of biofuels not only helps mitigate climate change, but also reduces dependence on fossil fuels, contributing to energy security. Autonomous flight. Autonomous flight technology is transforming the way aircraft are operated. Advanced algorithms, sensors, and artificial intelligence enable aircraft to perform tasks, such as navigation, takeoff, and landing, with minimal human intervention. Autonomous flight systems enhance safety, by reducing the risk of human error, and allowing for more precise and efficient operations. While fully autonomous passenger aircraft are still in the experimental stage, autonomous drones and cargo aircraft are already in use, demonstrating the potential of this technology. Dassault's Advanced Flight Deck. Dassault Aviation is at the forefront of developing the next generation of advanced flight decks. These flight decks integrate cutting-edge technologies to enhance pilots' situational awareness, reduce workload, and improve safety. Features such as large touchscreen displays, intuitive interfaces, and advanced avionics provide pilots with comprehensive information and control. The integration of synthetic vision systems and enhanced navigation packages further enhances the capabilities of Dassault's advanced flight decks, making them some of the most sophisticated in the industry. Digital Flight Control Systems. Digital Flight Control Systems, DFCS, have revolutionized aircraft handling and performance. These systems use digital computers to interpret pilot inputs and adjust control surfaces accordingly, providing precise and responsive control. DFCS enhance safety by incorporating redundancy and fault-tolerant designs, ensuring the aircraft can continue to operate, even if a component fails. The benefits of digital flight control systems include smoother handling, increased fuel efficiency, and the ability to implement advanced flight maneuvers that were not possible with traditional mechanical systems. Fighter jet technology. Fighter jet technology continues to advance, driven by the need for superior performance, agility, and survivability in combat situations. Modern fighter jets incorporate stealth technology to reduce radar visibility, advanced avionics for situational awareness, and powerful engines for high-speed performance. Innovations such as thrust vectoring allow for exceptional maneuverability, giving pilots an edge in aerial combat. The integration of artificial intelligence and autonomous systems enhances the capabilities of fighter jets, making them more effective and versatile in complex missions. Synthetic Vision Systems. Synthetic Vision Systems, SVS, provide pilots with a virtual representation of the environment, enhancing situational awareness in all weather conditions. SVS use terrain databases, GPS, and other sensors to create a 3D view of the landscape, runway, and obstacles. This technology helps pilots navigate safely, especially in low visibility conditions, by providing a clear and accurate depiction of their surroundings. The use of synthetic vision systems significantly improves flight safety and operational efficiency. Coordinated symbology. Coordinated symbology refers to the standardized visual cues and symbols used in aircraft displays to convey information to pilots. These symbols provide critical information about the aircraft's status, navigation, and environment in an intuitive and easily understandable format. Coordinated symbology enhances situational awareness by reducing the cognitive load on pilots and allowing them to make quick and informed decisions. The development of advanced display technologies, such as head-up displays, HUDs, and helmet-mounted displays, HMDs, further improves the effectiveness of coordinated symbology. Enhanced Navigation Packages. Enhanced Navigation Packages, ENPs, incorporate advanced technologies to provide precise and reliable navigation information to pilots. These packages typically include GPS, inertial navigation systems, INS, and satellite-based augmentation systems, SBAS, to ensure accurate positioning. ENPs enable aircraft to operate in challenging environments, such as remote areas and congested airspace, with high levels of precision and safety. The use of enhanced navigation packages is essential for achieving the required navigation performance, RNP, standards, and supporting advanced flight operations. Enhanced Vision Systems. Enhanced Vision Systems, EVS, use infrared sensors and other imaging technologies to provide pilots with a clear view of the environment in low visibility conditions. EVS enhance safety by allowing pilots to see through fog, rain, and darkness, improving their ability to navigate and land safely. The integration of EVS with other avionics systems, such as synthetic vision and head-up displays, provides pilots with comprehensive situational awareness, and enhances their ability to make informed decisions. In conclusion, the aviation industry is experiencing a remarkable transformation, driven by advancements in aircraft design and systems. From innovative designs and advanced manufacturing techniques, to electric propulsion, hypersonic travel, biofuels, and autonomous flight, these technologies are shaping the future of aviation. The next generation of Dassault's advanced flight deck, digital flight control systems, fighter jet technology, synthetic vision systems, coordinated symbology, enhanced navigation packages, and enhanced vision systems represent the cutting edge of aviation innovation. These advancements are essential for meeting the evolving needs of the industry, enhancing performance, safety, and efficiency, and ensuring a sustainable future for air travel. Thank you for joining us on this journey through the transformative technologies, revolutionizing aircraft design and systems.